Chapter 2 of this cybersecurity dissertation proposal mainly talks about two things. The first one is the data set that's going to be used in this proposal. The second thing is the data mining techniques that are going to be applied or related to the research. It's very similar to the writing paper. Usually you have chapter 1 or the section 1 start talking about introduction. Then the next two sections are discussing about your data set as well as the algorithms. So this proposal is following exactly the same logic of your writing paper experience. Let's start looking into the data set. The data set mentioned in this research proposal including the following 4 different data sets. The first one is the famous KDD, which is probably the most prestigious conference in data mining area, and that is the data set for the KDD published in '99. So this is a famous cybersecurity data set, and that's also something I want to talk with you guys about it. The second data set is the refinement of the KDD 99. So they have obviously removing some redundancies, so make the data more clean. UNM, University of New Mexico, also generate another data set regarding to the cybersecurity. So that is also something popularly available and being well studied. The last one is the intrusion data in the virtual environment. The link I provide over here is the place where I found all of the data, and I want to talk with you guys today. You can go over there and then find exactly the same things I have discovered as well as demonstrate in this video. So KDD 99 data set, here is some background information. In 1998, DARPA, which is the military, US military organization that tried to do an intrusion detection evaluation program, was prepared and managed by MIT Lincoln Labs. The objective is to survey and evaluate the research in intrusion detection. So at that time, it's a big thing already, not to mention now it's even more important. The standard set of a data set has been audited, which includes the wide variety of intrusions simulated in the military network environment. So that was the environment where the data has been generated. The 99 KDD intrusion detection contest used the version of this data set. So this is the subset of the data that's been public available, and a lot of people has been studying about this data set. So what is this data set? Lincoln Lab set up an environment to acquire 9 weeks of the raw data, and that's a while that try to record all of those traffic informations simulated by a typical US Air Force LAN. They operate the LAN as if it were true Air Force environment, but it actually tried to embed some attacks. And there are several different kinds of attacks has been embedded and try to see what can we capture or what can we realize what's going on. The raw training data set for 9 weeks consists of about 4 GB of the data. So those are considered as the raw data, and this was processed into about 5 million connection records. Similarly, that data set was being captured as the training data set, and then similarly, the 2 weeks of the test data set, which is after that, they record a separate set of the data to be considered as the testing data set. And that stores about 2 million of the connection records. So you can see that's how they prepare their training data set as well as the testing data set. And obviously they are independent to each other. And we have discussed enough knowledge about why should we separate the training data set as well as the testing data set. A connection is a sequence of TCP packages starting and ending at some well-defined times. Usually it's like 2 seconds. Later you will see this information. And so that what they're trying to do is that for every 2 seconds, they generate a data to see what is happening over there. For information records, including the following things. So for the data set, it will looks like it has the source IP, where does it comes from, where is that try to connect the target IP address. And then with each connection, basically they have a label. So they can label it as a normal traffic or it's an attack. If that is an attack, not only will say it's an attack, it will also say what kind of attack. So for example, those denial of service. So basically that is the kind of things that you have sending a lot of requests, and that request amount is over the server can handle, and that's the server will kind of shut down and no other people will be able to access the server. Next one, R2L is unauthorized access from a remote machine. So basically, someone is trying to guess a password. They are not supposed to be able to log in, but they logged in, and then they try to find the connections and then try to guess the password so that they can really get into the system. And of course, remember this is a military department, so the people who are not supposed to come in is basically need to be blocked outside of the server. U2R, basically this is like unauthorized access to local root or super user privileges. So this is different from the previous one. This is the one that people is already successfully logged in. Either they have the password or they can, if they went through this stage, they guess their password come into the system and they are doing something they are not supposed to do. So this is like logging users try to do something outside of their privilege. And there's another one, it's like probing. They try to look into the different ports and then try to find the vulnerabilities of the server. So that you can see they will record a lot of different informations together with a label indicating it is either a normal traffic or it's an attack. The data set, basically based on all the information we have mentioned, they have consist of 31 attributes. Many of those attributes are basically a result of the raw data. They try to summarize the raw data and then make them more or less meaningful. Otherwise, they are all binary data set, which is not going to be beautiful or easily analyzable. So this is like the data processing from the raw data comes into the 31 attributes. This is the first table of the first set of attributes, including 9 different attributes, talking about the duration, how long was the connection, protocol type, what kind of, this is TCP, UDP, etc. What kind of service, the number of data bytes from source to destination, number of data bytes from destination to source. So it's like upload and download, that kind of idea. There's some flags, then wrong fragment, urgent, of these kind of things. And you will notice that the data type are different. Some of them are continuous data type, some of them are like this is like TCP, UDP, etc. So the data types are not exactly the same. Try to map this knowledge into either clustering or the classification. When the data are different, they are not within the same range. How would you want to calculate the distance? How would you want to find the similarities and build a model out of it? They are all challenges. The second set of the attributes are including these things. So that's number of hot indicators, number of failed login attempts, and obviously all of these are related to the cybersecurity issues. Logged in, 1 if successful, 0 indicating otherwise. So they have they successfully come into the network. And then number of root access, number of file creation operations, number of shell prompts, etc. So all of these informations are related to content features with a connection suggested by domain knowledge. So you can see that to summarize these attributes, you require the basic knowledge about the cybersecurity or the networking, and that is the background information needed for the data science idea. The third set of the attributes is actually the derived attributes. So based on the data that we have, we can try to see number of connections at the same host at the current connection in the past 2 seconds. How many times have they continuous commuting? So that if that is a DDoS, denial of service attack, then they will actually come in a lot. So that's also important features to understand it. The next 5 attributes and the next 3 attributes are related to the following things. The first one is the refer to the same host connection. So what is same host connection? Same host connection explains only the connections in the past 2 seconds. So within this time frame, have the same destination host as the current connection. So they are trying to connect at the same location. That's considered as the same host connection. And based on that background information, we can generate those 5 different attributes. What's the percentage of having SYN arrows? How many of them have REJ arrows, etc. So these are very domain-specific knowledges and derive the attribute to support those knowledge. If you have different set of knowledge, then of course you can generate different set of the attributes to better incorporate your findings. So those are all the things that are related to the background information about the cybersecurity. The next 3 attributes are what we discuss as the same service features. So while the same service features examine only the connection that in the past 2 seconds, so using the same period amount of time that have the same service as the current connection. So are they doing the same thing basically? So these 31 attributes combines all together to form the data set of what we call the KDD99. So if you go into the link I provide earlier, you will see this kind of things. The task description is basically the introduction I gave to you guys. Then there are different set of files. So that the first one is a list of features. So they talk about those 31 attributes. Then is the data set over here. The full training data set after the zip is about 18 megabyte. After you unzip it, it's close to 743 megabyte. And then it has a 10% subset, which is much smaller, and that's what I plan to demonstrate to you guys. Have a quick feelings about that, and I also downloaded that file, included in the Blackboard, so that you can really take a look if you are interested. So that's a 10% out of it, so you can see that the original file is about 750 megabyte, the 10% is about 75 megabyte. KDD new test data set, so here is the testing data set as well as the you can see the test data set that is basically 430 megabyte, which is a testing data set, compared with another 10% of the data set as 45 megabyte. So I also including the testing data set so that we can take a look what it looks like. It also provides some answers to this testing data set, kind of like answers to the question. So this is the training data set, which of course is only 10% of that. So I try to take a snapshot of it. Obviously, take a look at the tab. You can see that there's actually a lot of things stored in here, and this is only 10% of the data. And basically, you can see that this one totally have about 500,000 of the lines indicating each data set, what it looks like. And like I said, there are 31 different attributes. So all of these attributes are corresponding to the information that we discussed earlier. In the end of it, they provide a label. If they indicating they are normal, that means they are basically the normal data. And if they have some different other things than normal, that indicating what kind of attack that's associated with this data set. So you can see this is the training data set looks like. For the testing data set, it has very similar structure, but there is no label. And of course, your job is try to make the predictive models reading those data set and then try to see what is the output or what is the label that is associated with. And therefore, you can see that this data set is actually a very interesting and nice organized data set, provide a lot of information. A lot of researches has been focused on this data set. So if you are interested, this is something that you can consider that as a starting point of the cybersecurity research area. And then after we look into the data set, it's time for us to take a look of the data mining techniques. In the data mining techniques, there are several subsections that's important to be discussed. The first one is feature selection, and that is something I want to discuss in this video. In the next video, you will see some quick introductions of classification, clustering, association rules, and correlation. Since in our data mining course, we have looked most of their algorithms listed in the proposal already. I will go over that quickly and then try to talk a little bit more about association rules to refresh your memories, since this proposal is mainly using the association rules. Let's take a look of the feature selection. For the feature selection, it's a process to find a minimum subset of features, which is essentially sufficient to solve the problem, such as those subset of the attributes can be used to build up a good enough classification. Take a look of the data set that we have. That's 31 attributes, and some of them are important, some of them probably not. And how do we filter out some of those and then make a more robust data set to build a good classification is always an interesting topic. Feature selection techniques consider two important aspects of the feature. The one is the relevance, how relevant it is to the label that we want it to associate. And you can see that this is different from the research problems. So if we are trying to find the, the password guessing attack versus if we want to look into all kinds of attack, that's going to be different. The redundancy is indicating that refers to its correlation with other features. Some of them are very similar. So do we really need all of those things? And that is something that we want to look into. So feature selection is basically this flow, very simple. Original feature data set, and then we try to use some subset, and we try to use that to do the evaluation. For example, build a classification model that we trust. And then we can try to see how is the prediction accuracy. If it is good, then that is a good subset. If it is not good, then we keep going back, choose a different subset and finding the best results out of it. And this loop may need to execute a lot of different times. And therefore, feature selection is always part of the data mining research, more or less like a data preparation part of the data mining research. So filter-based, there are two major approaches. The first approach is filter-based approach. So for a given data set of the feature, the later algorithm searches with a searching function f through the feature space to generate another subset of s. So try to filter some attributes out. An evaluation function is try to measure and then select a subset and replacing if the current subset exhibits a better result. So they can try to filter out. For example, in our 31 attributes, we can try to filter out starting with 2 attributes or having some approaches to take away some of them and then try to see the model. If they are still giving us similar results, that means the features that we take out is sufficient. It's good choice. If the accuracy drops dramatically, then we know we threw something important away. So that's some different interesting approaches that we can do. Another type is wrapper-based techniques. For wrapper-based techniques is that we try to find for each feature subset S generated by a search function f, and the learning algorithm evaluates the fitness of the feature subset by applying data mining algorithm on the data and evaluate the output. So what this trying to do is that they try to group, instead of taking some features out, which is like using a minus idea. The wrapper-based technique is that you try to select several of those. Out of 31, you select 8 of those, for example. And then you try to see how does these 8 features working together do. So this is more like a plus from 0 and try to get some subset of the features to work to see how does that working. And therefore, these are the techniques that we can use and can be used in this kind of cybersecurity and basically all kind of different things. Just like in the Y data set, we have close to 1,000 attributes. Not all of them are related to the Y quality. How do we find the best set of the results to generate the evaluation and predict the Y quality is also an interesting area. So of course, if you are interested in doing the feature selections, that's also something that we can work together or we can think about.